Good morning, good afternoon, and good evening. Welcome back to Chapter 6. We're talking about cellular respiration. When we introduced this chapter, we said that cellular respiration takes place in 3.5 steps. This is the first step, called glycolysis. First, let's break the word down. What does glyc mean? Glyc means sugar. What does lyse mean? Lyse means to break. So this process called glycolysis, glycolysis, we're going to break apart sugar. So we start with our sugar molecule, and here we see our sugar molecule. Remember, we're taking some liberties here. Remember that a sugar molecule should be a ring, and it's going to have oxygens and hydrogens attached to the carbons. What we're actually only just showing here is we're just showing the carbon backbone. We're only just showing just the carbons. And remember, when we talked about organic chemistry, we said you just got to kind of remember and assume that there's going to be oxygens and hydrogens attached to it. Don't worry about specifically where they are. Just understand that they're there and that we're going to use them. We're going to take them off, but it's not terribly important exactly where they come from, just that they're there. We're going to pull them off and use them, okay? So this is a representation of my glucose molecule, and what I'm going to do is I'm going to cut it in half. I start with my glucose molecule and I cut it in half. When I cut it in half, I get 2 ATP as a result. And remember, pause. Keep in mind, what are we trying to make this whole time? We're trying to make throughout this whole purpose. The reason why we're burning up this glucose molecule is because I'm trying to get the energy out of it. Why do we eat? We eat to get energy. The energy that we want to get out of our food is in this form called ATP. I'm trying to make ATP. An example is like, why do you go to work? You go to work to earn money, right? That paycheck, that's why you go to work. I want you to imagine then that you are a server. You're a waiter or a waitress. And what do servers, how do they make their money? Where does their real money come from? And the answer is their real money comes from tips. And there are two kinds of tips that servers get. They get cash on the table, or they get a tip on the card, on the credit card, right? ATP is cash. So in my first step, my first table that I weighted, my first set of tables that I weighted, I earned $2. What are you going to do with that money that you make? You're going to shove it in your pocket. That's what you're going to do with it, because that's why you're at work, to make money. NADH is the other kind of tip. NADH is a tip on the card. Now, if you've ever been a server, if you've ever been a waiter or a waitress, when do you get the tips on the card? You get them when you cash out at the end of the night. The manager brings up all the tips, adds up all the tips on the card, and then gives you all of the money all at once from the tips on the card. The money on the table, you put that right in your pocket, all right? The tips on the card, you have to wait until the end. You have to wait until the end of the night to get your money. ATP that we make, that's cash in your pocket. NADH, those are tips on the card. We have to wait until the end of the night to get them. How many tips on the card did we get right here? We got $2 on the table, and we got 2 tips on the card. Each NADH represents 1 credit card tip. We just made 2. All right? We ripped some hydrogens, we ripped some electrons off of my glucose molecule in the process of cutting it in half. And I added them to my NAD plus and turned it into this molecule called NADH. NADH is the tip on the card. NADH, when do we get the tips on the card? We get the tips on the card at the end of the night. We're going to send NADH to the last step, and the last step is step 3. We're going to send NADH to the last step, and we're going to deal with them all when we get there into step 3. Okay, so ATP is cash in my pocket. NADH is going to go to step 3. That's the tip on the card. We're going to wait until we get to the end to use it. So of the products that get made from splitting my glucose in half, this is the only one I have to carry with me, and this is called pyruvate. It's called pyruvic acid. All right, so glycolysis. Step 1. I start off with how many carbons in glucose? 1, 2, 3, 4, 5, 6. 6 carbons. And what do? I'm going to break glucose. I'm going to break my 6 carbon molecule into 2 3 carbon molecules. I'm going to break it into 2 3 carbon molecules. 1, 2, 3, 4, 5, 6. 2 of these. 1, 2, 3, 4, 5, 6. This is called pyruvate, or sometimes called pyruvic acid. They're not totally identical, pyruvate versus pyruvic acid, but for our purposes it's close enough, so we're not going to worry about the difference between pyruvate and pyruvic acid. Just work with me here. So if you ever see pyruvate or pyruvic acid, just understand it means the same thing. What are the other 2 things that we get when we break apart my glucose? We get 2 ATP, and remember, that's cash money. That's money in your pocket. You're taking it home. What are we trying to make by splitting apart this glucose molecule? What we're trying to make is this stuff right here. And so every molecule of this that we make, that's what we want. That's what we're trying to make. So we made it. We put that money in our pocket. We made ATP. The cell's going to use it for whatever it needs to use it for. I mean, what do you use money for? You use money for a whole bunch of different things. The cell uses ATP for a whole bunch of different things. It's just going to use it for whatever it needs to be used for. The other thing that we get is this thing called NADH. 2 NADHs. Remember, the NADHs are going to go to step 3, and we'll catch up with them there. This is cash in my pocket. This is tips on the credit card. I have to wait till the end of the night to get those. So if I bust this up, and these are the products of what I get from busting this up, then what's the only thing I have to take with me to step 1.5? 3.5 steps. The next one is the half of a step. The only thing I have to take with me are my 2 pyruvic acids. Step 1.5. Step 1.5 is called, well, I call it primer phase. It's not really called primer phase officially, but that's what I call it because that's what it was taught to me as by Dr. Deborah. Primer phase primes pyruvate, gets it ready, gets pyruvate ready to go to step 2. So what we do is we start off with my pyruvate. Remember, that's what I ended up with at the end of step 1. I start off with my pyruvate, and I'm going to cut one of these carbons off. What did we say? When you cut a carbon off, how do you release it? When I cut off a carbon, it gets released as carbon dioxide. And here it is, carbon dioxide. The carbon that I cut off gets released as carbon dioxide. Where that carbon was, I'm going to put in its place something called coenzyme A. And we have an idea of what enzymes are and what they do already. You know, the enzymes make a reaction happen. And I'll tell you what coenzyme A does in just a minute. But the purpose is, the point is, this 3 carbon molecule, because I cut off a carbon, is now a 2 carbon molecule. The one that I cut off, I release as carbon dioxide. The 2 carbons that are left, where that carbon was, I attach this thing called coenzyme A. Acetyl means 2 carbons. So acetyl coenzyme A literally means 2 carbons with a coenzyme A on it. When I do this, when I cut off this carbon and add that coenzyme, I make one more of these NADH things. Remember, NADH is what? It's a tip on the card. I take my pyruvates from the end of step 1, and that's what I begin step 1.5 with. So here's my pyruvic acid. My pyruvic acid from step 1, it's right here. What am I going to do? I'm going to cut off one of these carbons. And when I cut it off, I release it as what? I release it as carbon dioxide. In its place, where that carbon was that I just cut off, I'm going to add something called coenzyme A. I'm going to use a different color. Remember, this C doesn't stand for carbon, it stands for coenzyme, and it's specifically coenzyme A. So, 3 carbons, cut one off, releases carbon dioxide. The other 2 that are left, I add coenzyme A. What else do I get as a product? I get another NADH. I get another NADH. Now, just like we talked about what happened to my products of this reaction, now let's talk about what happens to the products of this reaction. What do we do with the carbon dioxide? You know what you do with carbon dioxide? What do you do with it? You breathe it out. So where does this carbon dioxide go? It goes away. You literally breathe it out. You literally breathe it out. We know what happens to NADHs. What happens to NADHs? They're going to go to step 3. It's a tip on the card. I have to wait till the end of the night to get my cash out from the NADHs. So if this gets breathed out, and that goes to step 3, what's the only thing left from these products? The only thing left is acetyl-CoA. The only thing that is left is acetyl-CoA. This gets breathed out. That goes to step 3. This is what we're left with to carry on to step 2.